Okay, welcome to part 2 of the identification of an unknown organic compound through spectra. Now, in our previous video, part 1, we used elemental analysis and mass spectroscopy to find the empirical and molecular formula, which is C4H8O. Now, if we go down and we see what other data we have, for example, the infrared spectrum, we see two very distinctive peaks above 1500 wave numbers. So in this peak here, this tells us that there are CH bonds in the molecule, which should seem obvious. But there's also a peak at 1700, which tells us there must be a carbonyl group, a C with a double bond to oxygen. Now, so we've narrowed it down to a certain functional group. We don't know if it's a ketone or an aldehyde, but because there's no peaks for an OH group, we can tell that it's not a carboxylic acid, and it doesn't contain any OH alcohol groups either. So infrared gives us some information, granted, not so much. If we move on to NMR spectroscopy, which is the most important of all of these. In standard level, you will not look at multiplets, but in higher level, which I'll do a video later on, you will see the increased use of NMR. Now, what does the NMR tell us? Well, we can see that there's 3 chemical environments, 3 different types of hydrogens. Okay, so an option you could do is you could draw a possible structure that has 4 carbons, 8 hydrogens, and 1 oxygen. And remember, we need a double bond to the oxygen. So we could try to draw a aldehyde where the double bond to the oxygen is at the end. We'll see that that doesn't work in a second. Because if you notice, there are 4 different types of hydrogen environments. And therefore, we should have 4 peaks in the NMR. So what are the 4 environments? We've got 1, 2, 3, and 4. We don't see 4 peaks, so it's not an aldehyde. That leaves us with the only other possible option, which is that our compound is in fact a ketone. So let's give it another go. What if we put, sorry about that, let's put the carbon here. Since my screen is not liking the spot, let's say we put the double bond here and fill up with the necessary hydrogens. No, doesn't like that spot. And here we go. Here we can see that there's 3 distinct hydrogen environments. Let's circle them with different colors. So this is one environment. The second environment here. And a third environment with a disappearing hydrogen there. Here. And that is what NMR tells us, that there's 3 environments. Okay? And the integration trace tells us of how many of each hydrogen there are, so that there's 3, 3, and 2. And that's perfect because we've got 3 blue, 3 pink, and 2 red. Now, what about the position of the signal? 0.9 means that you need a strong magnetic field because those hydrogens are far from any electronegative elements. So the pink one is this peak. Then the other 2 are a bit higher numbers because they need a weaker magnetic field because they're closer to this carbonyl group. So NMR has told us that the compound we've been looking at is butane 2-one, where the CO bond is in position 2. We would not have known this if we just had info from IR or mass spec. So NMR is a very powerful tool. With all this information, we've realized that this is our compound. Okay, I would like to give thanks to InThinking, which produces these wonderful worksheets for you to practice organic chemistry and IB chemistry. Thank you so much for listening.